to analyze the data itself, even before you build a model. Okay, you can do some visualization to understand some insights. You can also use visualization to answer very key business questions. We're going to look at some of them later in this particular presentation. And so we do agree that charts, okay, are very essential part of working with data. And so they are able to let us condense large amounts of data into an easy to understand format. Okay, so you look at the chart or you look at the graph and you go like, oh, okay, this is increasing, this is decreasing over time. And so visualization of data can bring out insights to someone looking at the data for the first time. Okay, and it can also help us convey findings to others who won't see the raw data. And so your managers, your stakeholders don't care about the raw data, right? They can't make sense of it. But if you're able to present it in a very intuitive and nice way, they are able to make business decisions off that. And so that is why there are countless chart types that are out there, and each of them can be used for different use cases. And so the most difficult part of creating a data visualization is actually figuring out which chart type is the best, as I mentioned earlier. So visualization of data, can bring out insight to someone looking at it for the first time, even, right? And your choice of chart type will depend on multiple factors. And so in this particular lecture, we are going to look at some of the factors that choosing a chart type depends on by looking at the most common chart types, when to use them, and testing ourselves with some questions, okay, and seeing if we are able to identify the type of chart that we want to use for certain type of problems, okay? So that's what we are going to do today. Let me just double check to see if, okay, yeah. All right, so the recording is on. All right, so we're going to start with the foundational four. Okay, we're going to start with the foundational four. So we will start off with the four basic chart types. Each one of them and what they do. Okay, so the four basic ones are extremely important because most of the other types are just variations of these four charts. Okay, so if you really understand these ones, you can easily identify the others. Okay, so I intentionally put this as the foundational four. So we will start off with the foundational four, which is the bar chart, the line chart, the scatter plot, and the box plot. Okay, and the box plot. The first one that we looked at was the bar graph. I think it's very, very common. Okay, so the bar graph, I would say, is a graphical representation of data using bars of different heights, right, and lengths. So let me get a pointer here. Here's a pointer. Okay, of different bars, okay, and height. What is important here is the length of the bar, okay, because that is what gives us the information that we need. Okay, so these three bars represent different categories. So what does it say here? The bars represent data or categories of data, and the height or length of the bar corresponds to the value or frequency of the data in that category. Okay, so here we are looking at purchases by user type. Okay, purchases by user type. That is let's say we have a website or a store and we have three distinct user types. We have guests, we have new users, and we have existing users. And we want to know out of these three, what is their purchasing power? Okay, which one purchases the most? Maybe that is the business question that we were asked. Okay, so you look at this and you can easily see that existing users purchase the most. Why? Because they have the longest buy here, which corresponds to the value more than 6K, right? So probably 8K here. Okay, so we can easily demonstrate such information using a bar graph. The important thing is that the y-axis normally represents values of frequency, and the x-axis normally represents category of data. Okay, category of data. So when can we use this? When comparing categories, to compare the values of different categories within a data set. These are different categories within a data set. Okay, existing user, new user, guest. Displaying categorical data. Okay, displaying categorical data. For example, our grade, we could have placed grade A, grade B, grade C, and here will be students. And we know how many students had grade A, how many students had grade B, how many students had grade C. Okay, because A, B, C, D, which are the grades, are categorical. So displaying categorical data, we can use the bar graph to represent data that falls into discrete categories, distinct categories, showing frequency or count. To display the frequency or count of occurrences in different categories. Okay, so each time you hear something concerning count or frequency, maybe what should come into your mind is a bar graph. Okay, highlighting differences between groups. Okay, and also visualizing, for example, survey results is very important. So it's important to know when to use what type or what form of a graph. The next one that we are going to have a look at is the line graph. Okay, the line graph is very important. Let's have a look. So a line graph is a type of chart used to show information that changes over time. Okay, so the most important thing here, okay, the most important thing here is changes over time. Okay, changes over time. So when you have a time factor, you want to consider line graph. So here, you're looking at changing over time, right? To show information that changes over time. It consists of data points connected by straight lines. Okay, so right off here, immediately you see that the question being asked you involves some time lapse, okay? Then you may consider a line graph. You're looking at changes over time. It could be months, it could be minutes, it could be hours. Okay, it could be sections like quarterly, annually, semi-annual. It does involve time. Okay, so let's look at when to use this. Obviously, showing trends over time because we mentioned time, right? And so showing trends over time is one very important aspect of a use case when you use it. Comparing multiple data series. Comparing multiple data series to compare the trends of multiple data series on the same graph. Identifying patterns to identify trends, cycles, or patterns in the data. Okay, so here we're looking at the stock exchange, right? So here, exchange rates from March, May, June to September, from March to September of the year 2020, I believe. And so you're looking at it and you are looking at the trend. So normally this is what you see, right? This is what you see on a stock exchange dashboard. Okay, so this is a line graph. Okay, they're looking at the various points and are being connected by lines. Okay, they're being connected by lines. So, for example, if you want to track student attendance, we can use a line graph showing the student attendance percentage over several months. Okay, so we can put the percentages here and the months here. So let's assume these are percentages. Okay, and these are our timeline. And so this means that 76%, this means that 77%, this means that 78%. We can then look at this and say, in May, we had a higher student attendance at peak level here. Okay. And in September, maybe most students were done with their project. And so we have a very low student performance, attendance percentage that dropped here. We had a drop here. Okay. And we can say that March, maybe school hadn't reopened. So students were coming gradually and all that. So assuming this was points for tracking student attendance. But this here is actually an exchange rate. Okay, that is what it looks like this. So we have talked about two. Bar graph and line graph. Okay, bar graph and line graph. So let me try something here just to make sure. Okay, so let's reflect on these two. So which of these types is best fit for trend analysis? So I'm going to set up a poll here. Okay. Just trying. Okay. So here. But today's date is 26th. Okay, so I think if you look on your screens, I've launched a poll there. Okay. So the poll is here. If you look at your screen, you will see a question which says which of these types is best fit for trend analysis? Is it a bar or a line graph? Okay. All right. Okay. So most of you got it right. That is fantastic. Okay. Yes, that's true. All right. So let's continue. We have the scatter plot. Okay. The next one we're looking at is scatter plot. So here, let's define what a scatter plot is and how we know when to use this. So a scatter plot is a type of plot or mathematical diagram to display values for typically two variables for a set of data. What does this actually mean? So if you want to measure the correlation between two sets of variables, then you use a scatter plot. Showing relationship between variables. So to identify the relationship or correlation between two continuous variables, okay? Detecting outliers. If you want to detect outliers or anomalies in data, okay, then you can plot the data points all over. So for example, if I want to look at a relationship between study hours and the grade of students, okay? So here, I'm looking at one relationship, and so it qualifies. And am I looking at two variables? If it is relationship, am I looking at two variables? Yes. I'm looking at study hours and grades. Then I can use a scatter plot because one, I'm looking for a relationship, and two, I have only two variables. Okay, two variables, study hours and grades. So that is one use case. Detecting outliers. Okay, outliers means that you want to see which data points are outside or are abnormal. Okay, so let's say all the data points are concentrated around this area, and you have one which is way off all of them, maybe here or somewhere here, and the rest are all here. Those data points which are way off, okay, from the concentration of most of them is an outlier. And also to identify clusters. Okay, so here we can see that these two are very close to each other. We can call it one cluster. We can also say that, oh, these two are very close to each other. This is a cluster. It means when we plot them in this Cartesian plane, they become close together. And so they may have some similarities. Okay, so we can find clusters based on this. So scatter plot here is a type of plot normally used for showing relationship between variables, two continuous variables, and detecting outliers. Detecting outliers is very important. So these are the two most common use cases for this. So immediately you hear about correlation, relationship. Okay. So we said continuous variable. Okay. So what is a continuous variable? What does it mean to say continuous variable? So a continuous variable is a type of variable that can take an infinite number of values. Okay. It can take an infinite number of values within a given range. So these values are measurable. Okay. And so normally when we say continuous variables, they are typically numerical and can take an infinite number of values. So let's say infinite possibilities. For example, a continuous variable could be the price of a house. Okay. It can be infinite. There are several possibilities. $2 million, 1.5 million, okay, 300,000, 150,000, infinite. You cannot box it. Okay, so in other words, or another characteristics is that they should be divisible. Okay, divisible. also measurement. They represent measurements such as height, weight, temperature, time. Okay, so continuous variable. Normally, they are numerical. So if we want to find a relationship between two continuous variables, dictating outliers, plotting and looking at the data points that are way off, okay, the range or way of the concentration of most of them, also identifying clusters, then we can use this scatter plot. The last one we're going to look at when it comes to the foundational four is this one here, okay? So this, I've changed the diagram to reflect a simpler meaning of this, okay? So let's try and look at the diagram here. So a box plot, let's look at the definition first. A box plot is actually very important, but you maybe rarely see it, but it's extremely important. A box plot is a standardized way of displaying distribution of data, okay? So the first thing you need to catch here is that it's a standardized, okay, way of displaying distribution of data. Okay. The next thing you need to understand, or we need to understand, is it has 5 number summaries. So you want to understand the distribution of data in these 5 summaries. What are the 5 summaries? The minimum. Okay. The minimum. Lower. Okay. The maximum. Here, around here. Where is my... And then first quartile, median, third quartile, and maximum. So let's look at this diagram. It makes it easier. So the lower tier of distribution. Okay. So for example, we are saying that we want to show the distribution of exam scores for different classes. Okay. Exam score for different classes. You want to show the distribution of exam score for different classes. Maybe level 100, level 200, level 300, level 400. Okay. Or first year students, second year students, third year students, whatever. Okay. You want to show the distribution of the scores for these students. Okay. And here we consider box plot because box plot allows us to show that distribution of the exam score based on these 5 summaries. So these 5 summaries are fixed, okay? And so we need to understand how they work. The first one is median. Okay, I'm just explaining, but let's look at from the here. So here you have quartile group 1, 25 percentile. Okay, so what is the distribution of scores for 25 percentile of the students in a class? Here, you go to quartile 2. Okay, this will be combined with this will be 50. This will be the 75 percentile because 25, 25, 50, right? So this will be 50 percentile. This will be 75th percentile. Okay. And then quartile 4 representing the maximum. Okay. So here, let's define some of the things we see here. Median, which is the middle quartile. This one, the median, the line here, the median, the middle. Why is it the middle? Because we here represents the 25th percentile. Here represents another 25th percentile. Combining these two gives us 50. And so this line here means this is the middle quartile. Okay, so The median marks the midpoint of the data and is shown by the line that divides the box into two parts. Okay, so for most of the box plots, you're going to see a line dividing it like this. Okay, and that line you see is the median. So this means that half the scores are greater than or equal to this value and half are less. Okay, so whatever score we have here, let's say, I think there's some annotations here. Let me use some of them here. Okay, so let's say this was a graph and you have 75 here. Okay, let's say this is a score. Okay, what this means is that half of the class had less than 75 here, and half of the class had more than 75. Okay, so this median, maybe this median is pointing to 75. From this representation, we know that half of the class had less than 75. Half of the class had more than 75, depending on what the median is. We call here the interquartile range. Let me show you quickly. Okay, this place. Where are you? Yeah, okay. This side, we call it the interquartile range. Okay, we call it the interquartile range. And what is it? So this is the middle box, okay? So the middle box represents the middle 50 of the scores for the group. The range of scores from the lower to the upper quartile is referred to as the interquartile range, okay? So the middle 50 of scores fall within the interquartile range. So here, the middle 50, okay? The middle 50, 25, 25 gives us 50. So the middle 50 of the scores will fall within this interquartile range. We're going to take an example and look at it. Then we have the upper quartile, starting from here. Okay, starting from here. Here. Where are you? This. Starting from here, okay, we have the upper quartile. Those who scored more than 75% of the class because they are here. Okay, they scored more than 75% of the class. That is the upper quartile. So 75% of the scores fall below the upper quartile. Okay, so this is the upper quartile here. And we are saying that 75% of the class score fell below this. Okay, because 25, 25, 25. Okay, that is 75. Fell below this. The lower quartile, lower here. This means what? 25% of scores fall below the lower quartile. Okay. So here, coming down here, okay, starting from here, okay, it means that 25% of the scores fell below the lower quartile. Here's the median, means 50% fell below. Here is the upper quartile, means 75% fell below this score. And then we have the upper whisker. So whiskers, the upper and lower whiskers represent scores outside the middle 50. Okay, so this and this, okay, these lines, yeah, they represent scores that are outside this 50, this middle 50. Okay. So if you have distribution where these lines are very long, okay, these lines are very long. It means that some students, when you're talking about scores, it means that some students had very low grades or scores. Others have very high, okay? But if you have all the students concentrated in the middle like this, and this whisker is like very short, like maybe here, okay, maybe here, then you would want to say that most of the students had very similar scores. Okay, so when do we use box plots? One, to display data distribution, to show the distribution of data and identify outliers. Yes, we can identify outliers here, okay? Because if sometimes when you have this, okay, you can also have, let me draw something here, okay? You can have some outside which is like this. These are outliers, okay? These, we can call them outliers. Some of the graphs, you're going to have this, and it will be represented by circles or dots, okay? And so these are outliers. They are not part of the identified groups, okay? So maybe students who didn't partake in the courses, okay? Or someone probably got 100% or something, okay? Way ahead of the class, okay? So we're going to look at examples and identify them. Comparing distributions. You can also compare. So I can plot this for level 100 students. I can plot another one for level 200 students, another one for 30-year students, another one for 4th-year students, and compare. Then I'm comparing distributions. And what else? Summarizing data. Okay. Summarizing data. So your boss comes to you and says, okay, so I need to know how much each of the sales team or groups are making. I'm talking about the sales groups in different branches in this company. I want to understand how much each of them are making, okay, as a group. Then you can plot this distribution for each of the branches and show it as a data summarized, okay? And so your manager or the stakeholder will be able to look at it and see the distribution, overall distribution of data, okay, concerning purchases and all. So these are the fundamental for, again, bar, line, scatter, and box. Okay, so let's say, okay, so let's see if we can do another poll based on this. Let me launch a poll here. Let's see if we can have a poll here. Where can I edit? Oh, okay, yeah. So let's prepare for a question. What type of chart would you use to understand the relationship between temperature and rainfall? So let me give you bar. Let's look at a line. Let's look at a box. And let's look at scatter plot. Okay. All right. So let's see if we can get this one. It's going to be there, but I'm going to move on to histogram. Okay, so a histogram is a graphical representation of the distribution of numerical data. Okay, so typically showing the frequency of data points within specified ranges. Okay, we can call it bins. Okay, so if you look closely at a histogram, okay, it is like a bar graph which has been combined. Okay, it looks like a bar graph which has been combined. So displaying frequency distribution to show the frequency distribution of continuous variable. Also identifying skewness, okay, to identify the skewness of data. Also visualizing spread and shape. Okay, so you would want to use a histogram if you are representing the distribution of numerical data, okay, showing frequency. Okay, so distribution and frequency, okay, at the same time. At the same time. Distribution and frequency at the same time. So here, okay, so some answers are coming in. Okay. So now the choice is really between line and scatter plots. Which one are you're gonna use to understand the relationship between temperature and rainfall? Yeah. Okay. So let's see. Let me just give another 1 minute, or yeah, for to finish the poll. Okay, and I'll give you the answer for it. Visualization, spread, and ship. Okay, so okay, just 1 minute more. If you have not answered the poll, you can answer it. Just you can just try. Yeah, based on your understanding, and then yeah, we see how to check again. Okay, so the question was to understand the relationship between two continuous variables. Okay. And what did we say is used to understand relationship is a scatter plot. Okay, so scatter plots is used to understand or show relationship between two continuous variables. Okay, so if you want to understand the relationship between temperature and rainfall, then we use a scatter plot. When do we use a line plot? When you are looking at trend analysis, showing trends over time. Okay, showing trend over time. Okay, so when there's a time factor involved, then we're looking at line graph. Okay, when there's correlation or relationship involved, then we are looking at scatter plots. When there's frequency involved, we are looking at bar graphs. When there is distribution involved, then we are looking at box plots most of the times, okay? Another one that we can use for distribution is a histogram. That is when you are considering representation of the distribution of numerical data, typically showing the frequency of data points within ranges, okay? Within ranges. Okay, that was good. Let's go here. All right, let's continue. Then we have a stacked bar graph. Okay, so if you understood bar graph, then this is easier. Okay, because it is the same thing as a bar graph. Okay, only the difference here is that in here, where is my pointer? In here, we want to compare total values and parts. So a stacked bar chart is a type of bar chart. It's a variation of a bar chart where each bar is divided into sub-bars, okay, stacked on top of each other, representing different categories. So when do we use this? If you want to compare total values and parts, okay, and you want to show composition over time, to show the composition of different categories over time. You can also use this, but normally we use it when we want to compare total values and parts. For example, here, okay, we are looking at the revenue as against the branches of these shops, these shop branches, okay? So we're looking at revenue and branches. Revenue and branches. Total revenue made by Sherry Street is above 12,000. That is 14,000. Okay. But out of the 14,000, clothing was 8,000. Equipment was 4,000. Accessories was 2,000. Okay. Looking at the range. So we are comparing total values. This is total values and parts. What is the composition of the total value? Okay. What is the composition of the total values? Same here. Strawberry Mall, Peach Street, Lime Avenue, Apple Road. So when you want to compare total values and parts, then you're looking at a stacked bar chart. For example, I ask you to give me the total number of Olympic participants from each country. Okay. And let me understand how many of them are athletes, how many of them are officials, and how many of them are how many of them are athletes and how many of them are officials. Okay. And probably staff. Okay, so you can have something like this for each country. You can give me the total. For example, Team USA have 90 participants, and out of the 90, maybe 40 are athletes, 30 of them are officials, and 20 of them are medical staff. Okay, so you can give me such data using a stacked bar chart. Okay, using a stacked bar chart, and you'll be able to represent the data correctly. So when you're comparing total values and parts, if the question you were asked involves knowing the total and knowing the composition of the total, then this is very important to use. Okay. All right. Let's continue. Grouped bar chart is the same thing. Okay. The same thing as stacked bar chart, but instead of stacking them on top of each other, we have simply put them by their side. We can actually do the same thing with a stacked graph. But let's see some of the unique use cases for this. A group bar chart or clustered bar chart is a bar chart where bars for each category are grouped together, but not stacked. Okay, so the only difference is they are grouped together like this instead of stacking them on top of each other. Okay. Comparing multiple categories, showing subcategory comparisons. Okay, same thing, subcategory. These are subcategories. Okay, subcategory comparison. Here. Where is this? Yeah, these are subcategories. Okay. We could have compared this to each other. They are subcategories of the entire revenue generation stream. So here, let's look at our example here. On the x-axis, we have 2020 quarter one, 2020 quarter two, 2020 quarter three, and 2020 quarter four. So 4 quarters, okay, in 2020, and we want to check revenue, okay, revenue for Kent, Lincoln, Mercy, and York. Okay, so 2020, we look at the revenue stream. Okay. And this is a unique case because you don't want to combine this into one. Okay. You don't want to combine this. You don't want to put this. You can, if you want to put it as stacked, you can find a way and do it, but it's better to represent it this way. Okay. Makes it look better because we are not combining their revenues into one. We are not interested in the totals of the entire group together. No. Okay. We just want to know each individual's total for the quarters. Okay. We are not interested in combining their totals together. If we were interested in knowing their totals together, as well as knowing how much each of them contributed to that total, then we can use a stack like this, okay, to do that. If we use a stack here, we have to do some subtractions and all. Okay, so it's better we represent such data this way. Okay, so here, same for here, and also for 2024 quarter. So because we are not interested in the total as a group, okay, we can use the group bar chart here. Okay, so that is one key unique case study or difference for this. Let's see. We have what we call a dot plot. Some of the graphs are non-essential. Okay, so the non-essential ones, we won't focus too much on them. Okay, we won't focus too much on them. The non-essential ones. Dot plot. A dot plot is a simple graphical representation where each data point is represented by a dot, as simple as that. Okay, displaying individual values, comparing frequency counts, to compare frequency counts of categorical data. Okay, so instead of using a bar graph, okay, so here, we could have used a bar graph, right? We could have drawn a bar from here to here, okay? We can use a dot plot, okay, by just looking at the heights, okay? So we could have done this with a bar graph by drawing bars here, here. Okay. And we can also use a dot plot to achieve the same thing. So comparing frequency counts, we can do this also with the bar graph. We can also do it simply with the dot plot. So the dot plot is a simple graphical representation. So a simplified graphical representation, okay, where each data point is represented by a dot. So if, for example, this is performance score, and this is the experiments that we made. Okay, so here we are checking performance score of several experiments. Experiment A, B, C, and the control experiment. Okay, and their performance score. Okay, so we can use a dot plot to achieve this by just plotting the experiment against the performance. Okay, so as this unique case is better to use a dot plot, okay, because we are not looking at frequency here. Okay, but if we were comparing frequency count, we could have used the bar graph or a dot plot. But for this unique case of displaying individual values, for example, here, we are just looking at the performance score as against experiment, then it's right to use a dot plot. Okay, so very unlikely to use this for frequency count because you would rely on a bar graph to do that if it is categorical data, right? Yeah. So normally for use cases like this, you can use the dot plot. As I mentioned, most of the others are just variations of what we know. Another, let's say, not very essential one is area chart. So an area chart is a graph that displays quantitative data with continuous lines and the area below the lines filled in. Okay, so instead of just having two line graphs here, okay, we decided to fill in the space, okay, with some colors. Showing trends over time, meaning we could have just used this line, okay, and it will become a line graph, two line graphs, okay. So this is a variation of a line graph. Okay, this is a variation of a line graph. So showing trends over time to visualize trends over time for one or more data series. So if it is this use case, you could have used a line graph also, or use this, okay. Comparing total and parts, okay, like we did for the stacked bar graph, comparing total and parts to compare the cumulative total and individual parts over time. Okay, so for bar graph, let me go back here. No, for stacked bar graph, we are comparing totals, okay, totals and parts, but no time value, not over time. Okay, but if you want to do this same thing like this over time, for example, just this branch, we want to compare their revenue over time, the totals and the individual values, okay, or parts over time, then we can use this area chart. Okay, we can use this area chart. So two scenarios here, showing trends over time, which can also be done by the line graph, okay? Comparing total and parts. If we were comparing just total and parts with no time value, then we can use a stacked bar graph. But if we are looking at it over time, then we have to use an area chart. Okay, why? because it's more like a time series. You can see it's like the line graph. Okay, it's like the line graph. Instead of just connecting with lines, we decide to shade it. Okay, yes. So as I mentioned, most of them are variations. They are variations of the foundational four. Definition: a dual axis chart uses two y-axes to plot two different data series with different ranges but a common x-axis. Okay, so this is more of a combination of a bar graph and time or a line chart. Okay, so when do we use this? To compare two data series with different units or ranges, showing relationship, to show the relationship between two different variables over the same period. Okay, so here we are also showing relationship, right? But over a period. Anytime you hear over a period, over a time, what should come into your mind is something concerning line, okay? So if you look here, we are looking at the overall customer acquisition cost over time. And on the x-axis, no, on the y-axis, we're looking at number of customers acquired, okay, here. We're also looking at customer acquisition cost. So we have a dual axis chart using two y-axes. One is for number of customers acquired, which is being shown by the um um by the bar graph here. Okay, January, February, March. So the x-axis is fixed. We are looking at from January to July, but we are looking at two things. One is the number of customers acquired, and two is the customer acquisition cost. So we are looking at two things. Okay, two things here. One is the number of customers acquired. Okay, and the second is the customer acquisition cost. Okay, so we are looking at a chart that is using two y-axes to plot two different data series with different ranges, but a common x-axis. Okay, so when we are looking at a scenario like this, then we can use a dual axis chart to achieve it. So from here, we are basically comparing the number of customers acquired as against the customer acquisition cost over January to July. Okay, so when you are comparing two data series or trying to show the relationship between two variables over a period of time, then you're looking at a dual axis chart. We also have the bubble charts. Quickly, the bubble chart is a type of chart that displays three-dimensional dimensions of data. Each point's x and y coordinates represent two variables, while the bubble size represents a third variable. Okay, so the other one that we looked at where we were showing relationship between variables was when we were actually looking at the scatter plot, right? So we mentioned that the scatter plot shows what? Two variables, okay? Relationship between two variables. Okay, so here we are looking at visualize relationship between three variables. Three variables, okay? So the difference between this one and the scatter plot is the number of variables that you are trying to look at the relationships that they have. So we can use, for example, a bubble chart showing the relationship between a budget, sales, and customer satisfaction. Okay, so with the bubble size representing maybe the satisfaction score of the customer. Okay, so we are going to take some practical examples. Okay, so when I launch the poll, okay, just try and answer. Okay, it doesn't really, just to know that we are understanding, so that if I have to go back and check some of the content or explain further, then I'm able to do that for you. Okay, so don't worry about that. You can always just feel free. So we're going to take some examples soon by looking at just this last two, and then we delve into practical. Okay, so pie chart, I think is this one is very common. So a pie chart is a circular statistical graphic, okay, divided into slices to illustrate numerical proportions. Okay, so we use this to show proportions. Okay, so how many students, okay, are male? How many students are female out of maybe 100 students? Okay, so the entire circle is 100 and you want to divide it into these percentages, right? We have seen it all the time. So showing proportions, to show proportion of different categories within a whole. Also visualizing part to whole relationship, okay? To visualize part to whole relationship in a data set. Okay, so how much of this data set, or what representation of this data set, okay, belongs to this category, you want to find out, okay, in a part to whole relationship. Quickly, the last one we're going to look at before we zoom into some practicals is funnel charts. Okay, so this funnel chart is used to visualize the progressive reduction of data. Okay, so if you look at the very nature of a funnel, you can see that it narrows in whilst it's coming down, right? So, for example, you launched an advertisement on Facebook or on social media, okay, and you want to represent how the advertisement did to the stakeholders, right? You can start by using something like this, okay? The funnel conversion chart, okay? So here, what is impressions mean? How many people the advert reached, okay? How many of these people the advert reached clicked on it? It has been reduced to 50 from 100, okay? And how many of those who clicked on this advert went to our landing page, actually called, okay, to acquire the services or the product? That is conversion, okay? So if this is 10% here, so it means that impression, clicks, conversion, we have a funnel representation. Okay, so a funnel chart is used to visualize the progressive reduction. So if the insight is progressively reducing in nature, then it's better to represent it with a funnel. Okay, so when to use this, visualizing stages in a process to show the stages in a process and identify potential drop-off points, tracking conversion rates, as this unique example that I have here provides. Okay, all right, let's get our hands dirty on some examples. I have over 10 questions here. Okay, so one, what would you use to analyze the distribution of student ages? Okay, so two things to note here. One, I'm interested in distribution. Okay. And two, I'm interested in age. Okay. Student age, which is numerical. Okay. So I'm going to launch a poll, narrow it down to some bar charts for you, and you choose for me which one you think you would use. Okay. So I'm not going to repeat the question because the question is on the board. So for tax one, which one are you choosing? Are you choosing yeah, let me reduce this to 3 choices for you to make it easy. Um, and let's say line chart. Okay. So here you go. So I'm going to launch this. It's going to appear on your screens. Okay. Just help me choose which one you're going to use. Are you going to use a histogram, a bar chart, or a line chart? Okay. So we have 2 minutes to select our answer. Okay. Okay. So analyze the distribution of students' ages. Which one do you think is correct? Is it a histogram? Is it a bar chart? Or is it a line chart? You will see on your screens. Select one for me. We have 1 minute, 30 seconds more to do this. Okay. All right, that's correct. So most of you got it correct. Yeah, most of you got it. Just 30 seconds more. 30 seconds more. Uh, is it a histogram? Is it a bar chart? Is it a line graph? If you want to analyze the distribution of student ages. Okay. So keywords here, we're looking at distribution and we're looking at numerical value, which is ages. So out of these, which one do you think we can use to look at the distribution? Okay, so we mentioned that we can use a histogram. Okay, so histograms are ideal for showing the frequency distribution of a single continuous variable. Okay, so continuous variable. Age is a continuous variable. Okay, it can be infinite. Okay, making it easy to see how student ages are spread across different age ranges. That's good. That's good. Yes. Let's move to another one. So here we want to compare the number of students in each grade. Okay, so here we're looking at comparing categories. Okay, category A, B, C, D. Okay, we want to compare the number of students in each grade. So for tax two, what do you think? So for tax two, what are you going to use? You want to compare the number of students in each grade. So frequency. Okay, we're looking at frequency here. So what comes into mind? Frequency. What comes into mind? Frequency. Frequency, what comes into mind? I'm going to launch the poll soon. So just a couple of minutes to think about it. Okay, let's go. So here we go. Frequency. Frequency. we want to compare the number of students in each grade, okay? We want to look at the visualization and go like, oh, this number of students are in this grade, this number of students are in this grade. So we want to compare. We're looking at frequency. Okay, we want to compare frequency. And so two things to know: categories, frequency. What comes to mind? You have categories A, B, C, D, F. Now frequency. What comes to mind? Okay, interesting results coming in from here. That's good. Okay. Compare the number of students in each grade. A, B, C, D, F. Compare the number of students in each grade. We're looking at categories and we're looking at frequency. Okay, so what do you think? What do you think? Is it a bar chart? Is it a line chart? Is it a scatter plot? What do you think? Okay, so let's look at the answer. And the answer is it's a bar chart. Okay, yeah, most of you got it right. It's a bar chart. So bar charts are effective for comparing the counts. Okay, the count, frequency counts of categorical values of variables, making it clear how many students fall into each grade category. Okay, we still have some time. Let's do a couple more. Let's do a couple more. Yeah. So the next one we're going to look at is this. We want to observe the trend. Okay. So keyword here, trend of average attendance over time. Okay. Two things you have to notice here. Time, trend. What comes into your mind? Time and trend. Time and trend. Okay. What comes into your mind? So tax three. Tax three. We're looking at time. So is it a scatter plot? Is it a line chart? Or let's say, can we use histogram for this? Okay. Tax three. So what comes into your mind? Observe the trend of average attendance over time. Time. Trend analysis. Time. Trend analysis. What comes into your mind? Time, trend. Example, monthly. Okay. So what comes into your mind? Is it a scatter plot? Is it a line chart? Is it a histogram? You can select from the options. Okay, some have already answered. Okay. Okay. Looks good. Okay. Okay. Yeah, most of you getting it right. Yeah. Line, scatter, and histogram. 30 seconds more. And we move to the next question. Okay. All right. So this, we're looking at trend and we're looking at attendance over time. Okay, attendance over time. So definitely we are talking line charts. Okay, so line charts are perfect for showing trends over time, allowing us to see how average attendance changes month by month. Okay, in our specific use case. Okay, let's go to the next one. To compare the average previous grade between male and female students. Okay, so um let's let's look at this critically. Okay, in our data sets that we have been using, we had a column called previous grade. Okay, so now I want to compare the average previous grades between the male and the female students. Okay, the average previous grade between them. So I want to have some sort of distribution where I can look at it and compare. Okay. Now look at the ranges and compare. So for tax 4, when we're looking at some sort of distribution and comparison between two categories, and it's also distribution, what are we looking at? Okay. So here, let's go in for, is it, can we use an area chart for this? Can we use a box plot? Can we use I'm gonna launch it pretty soon. Save this. It's waiting for. Okay, so which one are we gonna use? Compare the average previous grades between male and female students out of area chart, box plot, and scatter plot. Which one do you think will be good enough to be able to achieve this? I know this will take some time. Yeah, so think about it and let's see. Mhm. So we want to compare the average previous grades between male and female students. Okay, so area chart, box plot, or scatter plot. We want to compare. Okay, so let's see. Let me review the answer here. So the answer is box plot. Okay, so a box plot summarizes the distribution of a continuous variable and make it easy to compare between different groups. Okay, showing medians, quartiles, and potential outliers. Okay, um, an area chart, okay, is like a line chart. Okay, which can also do the work of a stacked bar graph when considering time. Okay, an area chart normally has a time value or component to it over time. Okay, over time, over time. Okay, over time, right? So here we want to compare the average of previous grades between male and female students, we can use the box plot because the box plot gives us the distribution. Okay, the box plot gives us the distribution, okay, to find the median, to find the quartiles and potential outliers, as we mentioned, okay? Nice. We will take this one and two more, then we can move on. I want to show the proportion of students participating in extracurricular activities, okay? Proportion of students. If I have 100 students, I want to know how many of them, proportion, okay? Yeah, that's correct. Proportion. So let's see what we have here. Proportion of students. So if I want to show the proportion of students, what do I use? Proportion. Proportion out of the whole. What do I use? I'm going to launch the poll soon. Proportion out of the whole. What do I use? Great. The answers are coming very fast for this one. That's excellent. Yeah. Proportion. 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 Show the proportion of students participating in extracurricular activities. Okay. Great. Okay, that's good. We want to show proportion of students participating in extracurricular activity. Okay, that's good. So we are definitely just 20 more seconds. All right. So we are definitely looking at pie charts. Okay. So pie charts are useful for showing proportions and percentages of a whole, making it easy to see what fractions of students participate in extracurricular activities. Great. Let's take just two more and we can call it a day. I want to analyze the relationship between attendance and current grade. Okay, so I want to analyze the relationship between two continuous variables. Okay, or two variables. Okay, two variables. Relationship, two variables. What are we looking at? Relationship, two variables. Are we looking at a line? Are we looking at a scatter plot? Are we looking at area chart? What are we looking at? I'm going to save this here. And I'm going to save it as a meeting. And then I'm going to launch it. Yeah. Let's see. Analyze the relationship between attendance and current goals. Okay. Relationship between attendance and current goals. What do you think? Is there a scatter plot? Is there a line chart? So you have relationship. You have two variables. Relationship, two variables. What do you think? Relationship, two variables. Which of them do you think is appropriate for this? Okay. So So the right answer is scatter plot. Okay. So scatter plot is used to display the relationship between two continuous variables, helping to identify any correlation between attendance and current grade. Okay. So area chart is is used when you are comparing two trends. Okay. So as I mentioned, area chart always has a time factor. Okay. So whatever you are comparing is over time. Okay. But here we want to have analyze the relationship. So scatter plot, bubble plot, they help us analyze relationship. Scatter plot is for two variables. Bubble plot is for three variables. Okay, so scatter plot display the relationship between two continuous values, helping to identify any correlation between attendance and current grade. Let's take the last one quickly. And then, yeah, display the average teacher assessment score for students in different groups. So we have a value and different categories. What can we use to solve this? This is going to take some time. Let's see if we can figure it out. Okay. So let's analyze it together. Okay. So display the average teacher assessment scores. So we have the teacher assessment scores for different groups. So you have groups and score, value and categories. Okay. So can we use a bar chart to do this? And I'm going to make it very close. I'm going to put in histogram also there. And I'm going to use a stacked bar chart also there. Yeah, very similar stuff. Let's see. So there you go. Which one can we use to display the average teacher assessment score for students in different groups? So you have different categories, okay? And you have a value. Okay. So all these three are very similar. So let's see which one you choose. Okay. 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 30 seconds more. And then we move to, then I can close this. 30 seconds more. What do you think? A bar chart, a histogram, or a stack bar chart? What do you think? What do you think? You have assessment score here, and then you have different socioeconomic status groups or categories. Okay, so let's see. Let's see. The answer is a bar chart. Okay, you can also argue for stacked bar charts because you can tweak in a way to do the same thing, but you can actually use a simple bar chart for it. Okay, so bar chart can effectively compare the means or the means of the continuous variables across different categorical group. I can actually show you for this one here. Oh, switch to so so for here, right? So we have the different socioeconomic status, high, low, median, and then we have the teacher assessment here. Okay. If you're talking about stacked, if we put this on top of this and this on top of that, then it becomes a total. Okay. It becomes a total. But we are not interested in a total. And so we can use a simple